So hi, I'm Michał. I work not that far away, just 1 kilometer away. So I decided to jump here. I work in Microsoft for quite a while, almost 10 years. So I work in Microsoft for quite a while. When I joined Microsoft 10 years ago, I was probably the only person in Poland, in Polish subsidiary that knows Python, and was coming mostly from open source projects, not really commercial ones. Now it's definitely different. So yeah, I'd like to basically talk briefly about what we are doing in open source space, and mostly with regards to Python and data science. It's also a good opportunity for me because we've announced quite a bunch of new products and projects last week. So instead of just focusing on just the topic of this presentation, I also decided to sneak in and do a quick lap around of maybe another interesting projects, just for your curiosity. If you would be interested in learning more about them, I would obviously it would be a pleasure for me to come here once again and maybe do a dedicated talk on some of these projects. So, as you've already heard, this is about Microsoft, and quite often, especially a couple of years ago when we were talking about Microsoft, it was about either this big bad company versus open source and some sort of paradise that was promised by, for example, open source community. It's obviously not there anymore. We are investing a lot in, first of all, internal capacity, and also more and more projects that we are releasing are basically very open and free of charge. So indeed, it will be about Microsoft, but you will see hopefully that there are quite a bunch of interesting things that you might have access to if only you wish, without spending a dime. So let's start with something that is kind of maybe obvious to some of you. I don't know how many of you have used the cloud, or Microsoft Cloud, meaning Azure. Yeah, it will be about cloud, but not only the cloud. So 3 years ago, more or less, we launched a project called Azure Machine Learning. It was kind of a tiny thing, mostly focused on aspiring data scientists, or the people who just willing to learn the data science, not really data science professionals. And basically, we were overwhelmed by the fact that it gained such a strong popularity. So first of all, what it does, it provides nice visual interface for building your own custom models. And that's like a history, right? So I don't know if you've used it at all. It also provides nice R and Python extensibility. So if you're a Python developer or R developer, you might find it also quite convenient. From my perspective, the biggest advantage, besides the fact it's a very good learning tool, so almost no learning curve, a lot of examples available out of the box, browser-based interface, literally no cost attached. The coolest part was also the possibility of turning those models that you've created in this tool into something that can be consumed by developers. Right, so that's something that most likely, if you're just starting to work as a data scientist, or work maybe already in data scientist team, you are not thinking so much. So how basically turn your work into something that will be consumable by external audience. And that's also, it may become very tricky. I have a luxury of working with plenty of customers, and I know, for example, certain banks that have a data science team dedicated for certain processes or projects. And once they've done the model, it takes roughly 6 months for the model to be deployed, right? Because basically, actually, the actual code needs to be rewritten and audited by the development team, right? So this amount of time is really painful for those people that need to actually wait in line for some things to happen. So that's actually obviously makes those things much less painful. As I said, it's just a matter of few clicks to make the model appear as an actual web service. And there is also, by the way, one hidden gem that most likely you don't know as well. There is one nice library, Python library called Azure ML that basically takes a piece of your code, and without touching the UI, you can simply turn it into or publish it as a web service. So this is very basic example here. As you can see, we are just publishing certain function using a series of decorators. And once you run it, it will become an effective scaled out web service that can manifest or can expose your model to external audience. So that's like the history, the past. Let's think of the future or actually the present. We've learned a lot. We are hosting right now hundreds of thousands of different models from hobbyists and professionals alike. And what we've heard, we actually started to interview a bunch of companies that are really into data science, so not really the starters, but rather the professionals. And what they told us, actually, yeah, they like the visual idea, but they sometimes prefer to use code. And I get the point. That's certainly the case. If you're doing something in Python, Scala, or R, it might be quite painful to turn it back into some visual tool. On the other hand, when it comes to extensibility, basically they want everything, right? So any new and cool library or framework that is available, right? We are now talking about TensorFlow or PyTorch or anything else. It has to support pretty much anything that is available on the market or will be available on the market soon. So that's basically what we've heard. And if you would look at the whole spectrum of the information that we've gathered, it's actually quite interesting because it's not just about accessibility of tools or commercial versus open source. It's also the fact that more and more people actually are willing to do something with AI. And this is also what we are seeing from customers. The hype is really high right now. So if you talk about AI, everyone tries to understand something from it and wants to have it deployed almost immediately, right? So there is definitely a demand on the market when it comes to professional skills. That's something that is currently missing. What is also important is this hybrid story. So quite often it happens that we are lacking certain hardware resources to finish the computations on time, right? So imagine we are using deep learning, right? And probably some quite sophisticated models consisting of multiple layers. You can guess how long it takes if you are not having a proper equipment. And if you look at the prices of GPUs that are currently happening on the market, or maybe stock price of NVIDIA, you may basically be lucky if you are able to buy some GPU hardware in reasonable prices. So maybe it would be a good idea to somehow rent it. Hint, use cloud for this sort of pre-computations, right? You can compute the model somewhere outside of your environment, and then once it finishes, you can simply take it back and deploy it anywhere else. Or vice versa, right? You can, for example, have the model being computed internally because, for example, of data sensitivity, but it can be after it is deployed, after it finishes, it can be deployed on some other hardware or software. So these sort of hybrid scenarios are becoming pretty much common now. And we are also talking about something that is called edge, meaning actually how to make those models really tiny that you would be able to deploy it on, for example, IoT devices, right? So that's another story and another trend in the market that we are seeing. What is also important, obviously, a plethora of different hardware platforms. So it's not about CPU anymore, it's also GPU, FPGA. There are a lot of different new hardware architectures that it would be good to somehow not touch at all. But unfortunately, if you are talking about data science, you need to be somehow aware of what those acronyms really mean. And when it comes to practical examples, we see a lot of issues with data preparations. Again, quite an obvious statement that data scientists spend 80% of the time basically preparing the data and then 20% of the time complaining about it, right? So So that's certainly true. I see it basically on a daily basis. When you are starting some new project with the customer, it usually takes between 6 to 8 weeks until the customer is ready to hand over the data, the first data set to my team. This is basically depicts how long it takes to make the data ready. Model deployment and management, this is basically the main topic of this presentation. So how basically deal with different ways of model deployment and management. Model lineage and auditing, again, very common topic nowadays, somehow connected with big data as well. There is a gap on the market that we see that needs to be somehow resolved. Explainability, we are talking about deep learning, for example, versus decision trees. For some industries, this is really crucial. And the last part is basically lack of formal process. And let's start maybe with this process. So this is one of the outcomes that we've published quite recently. It's called Team Data Science Process. So it's kind of an outcome of our internal work. You may guess that inside Microsoft, for internal purposes, we have more or less, let's say, 1,000+ data scientists working full-time in different teams, different groups, but they need to somehow collaborate and share the work, not just externally, but also internally, right? So if you are working alone, that perfectly makes sense, but if you are trying to build a proper professional practice, it might make sense to obey to certain standards. And there is lack of those standards, at least, like de facto standards. And obviously, we've got some history when it comes to software development. So for us, it seems quite obvious that there are some similarities when it comes to developing software and developing models. So that's basically a simple picture depicting all the steps when it comes to model management and model data preparation, data acquisition, etc. So what comes besides this picture, besides this nice picture, you can see the GitHub page that basically has all the necessary artifacts. And I found it quite interesting because especially if you're working in consulting business, you usually are working a lot with papers, so it would be good to somehow document what you're doing. And there is a set of templates that is provided out of the box. You can simply populate with your customer data. So starting from project charter, ending with exit report, you can basically reuse this sort of formal approach to document the work that you're doing. And obviously charge your customer for it. So that's like out of the box as part of the team data science process. There are also some nice tiny tools that can help you, for example, with data manipulations, but that's like a side projects. And this is obviously something very, very alive. So that's like an internal stuff that we are using already in production for a few years already. Okay, so let's talk about data or model operationalization. If you think about it, there are two ways of dealing with that, especially when it comes to big data world. You need to think twice where actually to put your model in, right? You can either keep it inside application. So you've got, let's say, this database layer and application on top of it, and all the intelligence or your model will be basically kept as part of the application. And that's fine for, let's say, small to medium-sized systems. On the other hand, you can do it in reverse, right? So let's keep the application thin, but as the database or your data lake or whatever you call it is getting bigger and consists of a majority of the data, it would be good to deploy the models as close to the data as possible. So those two variants are perfectly okay, depending on your scenario. So the question is when to choose what. And we actually give the choice, right? So we are not enforcing any of those paths. Rather, we are just following the trends on the market. And that's basically quite recent poll from KD Nuggets. You can see what are the top 3 most popular data science languages. Python has just overcome R this year for the first time, so congratulations. And SQL is the third one. So it looks like it would be good to somehow understand those three communities if you're willing to do something to the community. So going back to the original picture, as I said, we give choice, right? So we give alternatives. First one, the most obvious one is obviously you can either go with the cloud, Microsoft Cloud in this case, or rather keep everything on-prem. So you don't want to touch cloud for any reason. And let's start with the first scenario. So let's assume that you have all the data in-house, you don't want to touch it, you don't want to migrate it to any other location. What are the options here? And funny thing, yesterday we've just announced a new version of SQL Server. Basically, probably everyone knows what SQL Server is. From version 2016, so from 1 year, we are supporting machine learning, or actually we do provide something that is called machine learning services as part of the database. And the purpose of it, first of all, it does support R and Python at the same time. The purpose of it is to reduce the time that it takes to take the data out of the original data store, right? So again, one example, our consulting services have been working with one of the customers on quite a basic machine learning model. So it wasn't a big deal when it comes to computation time. But it took roughly 20 minutes to load the data into the memory from multiple sources, just to take it out using ODBC or JDBC, whatever they've been using. So you will see some obvious overhead when it comes to the fact where the data is being stored and the fact that you need to, in most of the cases, load the data into your computer memory. So what we are doing now as part of the database, we are basically relying on the data that is already stored there. If you're using relational data, and in many cases you do rely on relational data, you can just keep it as it is and just apply models on the data that is stored in the database. You are not taking the data out of the database. So obviously it's quite convenient, because if you look at, for example, data scientists, you might be using some small laptop or workstation and have like high-end database server, and all the scripts that you will be writing in your workstation will be effectively running using database resources. So there will be no data transfer between those two machines. You can just be rest assured that proper resources will be allocated on the database side. So that's kind of neat. On the other hand, what is also nice, if you are a model consumer, let's say you don't know much about Python or R, you would just like to have some output from your model, you can just execute it using just plain and simple stored procedure, right? So you can embed, or you can ask your data scientist friend to embed his or her code as a stored procedure inside the database, and just rely on the stored procedures for the actual, let's say, predictions or model calls. So that's nice. What we've also announced with the newest release of the SQL Server is also native extension to TSQL syntax called predict. There is a dedicated command that allows you to natively call certain models that are already serialized in database. And that basically means that you are able to, for example, call 1 million, you can have 1 million calls per second when it comes to your model scoring. So for the really high performance solutions, this is something that we definitely suggest. Okay, and there is also another product or project that we made available called Machine Learning Server. I was talking about database and the fact that you can embed your code and model inside the database. If you don't want to, you're not using, for example, SQL Server, you are using some other database, you can still expose your code through, in this case, REST API using the product called Machine Learning Server. So once again, it provides you with this nice wrapper on top of your code, on top of your model, and also provides you with some additional features like model manageability. So you can, for example, version your model and keep it in the safe place. By the way, those features are also available in the Express version of SQL Server, so you can just go ahead and download the Express edition of SQL Server and play with it as it is. Okay, so that was like the in-house story, on-premises story. Let's look at what has changed in the cloud since last week. We've announced new version of machine learning services. This time it's not just a web interface anymore. So as I said already, there was a lot of demand when it comes to different ways of deploying the models. For example, what to do with the model that has been constructed in cloud. We would like to now host it in our local data center. Is it possible? So starting from last week, it is indeed possible. How can you make it? First of all, we've announced two new services called Experimentation and Model Management Service. They are separate for a reason. So Experimentation is basically access to the tools that I will be mentioning about in a few seconds. Model management is all about model versioning and maintaining the production model. So, right? So this is the place where you can actually host multiple versions. You can provide proper SLA to the solution, etc., etc. On top of that, we are providing a dedicated, this time, desktop interface. So there's a client application working on Linux, macOS, and Windows, obviously. That gives you a possibility to basically create your own models using Jupyter notebooks, for example, or any other code editor you like. So there are two services. There is one new desktop application, and the way to publish the models or the outcomes of these models onto multiple different environments. So you can see now that you can either just rely on the cloud and use, for example, Spark coming from Azure, or GPU-enabled virtual machines or container services that we have as well. You can go and deploy it on Edge, as I said. So this is the story for everybody interested in IoT services. But you can also take this piece of code and deploy it directly locally using, as I said, SQL Server, but maybe Docker, right? So in this case, just to be clear, we are not relying or enforcing any specific, in this case, Azure service. It can be your own infrastructure. We are using pretty much standard Docker containers to maintain the code. So when it comes to experimentation, it's the crucial part, because quite often it takes a long time to basically, first of all, prepare the data and then apply all the transformations. And especially when it comes to deep learning, to finish the computations. So you can just send it, for example, to some GPU-enabled VMs. And then once you have the model ready, it's pretty much Docker. So we are using Docker containers. And once your model is Dockerized, you can deploy it anywhere. And obviously, there might be a question, what the hell is Docker? That's a good question, because if you're a data scientist, you don't really care about it. And that's basically the purpose of this tool, right? So instead of learning, how to, first of all, create the container and then maintain it on the proper scale, you may just rely on the tool that basically does it for you. So that's the story when it comes to model management. The cool thing about it is also we are not trying to forget about our, let's say, old school audience, Excel users. They still exist, believe it or not. So for them, we do have nice integration with these new services. This is still upcoming, so we are expecting it to be released in the coming, let's say, few months, let's say 1 quarter. And there will be an option to basically embed your models as a function inside Excel. So it won't be basically part of the Excel, but it will call your model directly from the Excel interface. So it's also quite neat, I believe. Okay, I probably will skip the pricing. We made a mistake when it comes to Azure Machine Learning because it was damn cheap, and we've unfortunately we're not be able to make a lot of money out of it. It looks like we are doing the same mistake once again. So you can see that the free tier basically allows up to 2 users to use it forever for free. If you're maintaining up to 20 models, again, it's for free, including the compute resources. So for the small shops or hobbyists or individuals, I would say it's generally for free. If you're going, bigger, we hopefully you will start to pay for it finally. Okay, and there are some other things or frameworks or toolkits that we've released quite recently. I think it would be relevant for you to be aware of them. There is one open source framework called MLSpark, and this is basically the way to integrate on top of Spark cluster, basically deep learning models. So there are a couple of ideas behind. First of all, it's mostly suited right now for image processing. So if you're doing a lot of image processing, the biggest challenge obviously is to keep your models close to the data. Here we are basically integrating through MLSpark, OpenCV and CNTK, or how is it recently called, the Cognitive Toolkit Framework. So you can use it to either use one of the pre-trained neural network models that are coming together with the framework, or you can start from scratch using some of the features of the framework as well. And that's totally free, so it's available on the GitHub as well. I was talking also about GPU resources. As I said, it becomes very scarce now. I must say that this is probably the hottest service when it comes to Azure. Constantly, we are trying to make some new purchases with NVIDIA, and it gets really crazy now. But hopefully, we are on the priority list, so you can still consider them as available. There is new series of machines called ND series with new GPUs on top of it, P40. You may also look at the comparison of P40. I'm not working for NVIDIA, but I'm not, whatever. So that's comparison of K80. So like a previous wave of professional GPUs that NVIDIA provided versus P40. You can see that there is roughly 3 times performance boost when it comes to image processing. So using different frameworks, in this case, Caffe and Cognitive Toolkit. Okay, and I know that I probably have confused you a lot. So this is like a cheat sheet, how to basically navigate when it comes to our offerings, at least part of it. Depending on what kind of scenario you have in mind, you can either go and build your own model or rely on our APIs. You can go with cloud or on-prem. You can pay for it or not. Better pay for it. That's basically the short cheat sheet. And as I said, it looks like this word is not divided anymore as it used to be, right? So there's no more cloud or not cloud, right? It's quite often hybrid. It's quite often not commercial versus open source, because once again, a lot of commercial vendors are doing a lot of cool open source stuff as well. So it's up to you to obviously decide what would you like to use. If you, for some reason, would like to stay close to the projects or frameworks that I presented, here's the contact to me, and obviously, if there are any questions, I would be really like to answer them now.
Okay, we have time for questions. One in the back. Front of the room is not really active today.
Okay, so when are we going to have P30s on Azure?
So Azure is very broad term. You can actually sign up for now for the private preview if you are interested in P40s. I can try to arrange that. If you are just considering GPU resources, there are still N series available. So unless you've tested the previous wave of our GPUs and you are not satisfied with the performance, I would highly suggest to start with what is available out of the box. If not, just ping me and I'll try to arrange access for that.
More questions? From the back? No? Oh, there's one.
I don't know if you have any contact with the Microsoft CNTK development team, but I'll try my luck. Do you know if there are any plans on implementing OpenCL support in Microsoft Cognitive Toolkit?
I don't know right now, but I can check because I do have those contacts. So yeah, if you shoot me a mail, I can put you in contact with the proper guys. Well, the plan is to actually to standardize it. I don't know if you've heard about the joint initiative of Microsoft and Facebook. I believe it was announced early September to basically make all the frameworks kind of standardized, at least when it comes to model transfer, right? So that's the like the ultimate goal. And by the way, I just had a pleasure to attend the session when we were reviewing, I believe, 5 or 6 major deep learning frameworks, basically from the Python developer perspective. All of them are so similar that there should be some way to make them compatible. But yeah, when it comes to Cognitive Toolkit, that's definitely on me. So just let me know.
Okay, one more. Are you going to join the after party today? Might?
I'm not really sure yet, but
Okay.
hopefully, yeah.
Wait, no message. If not, I think you can find Michał after our last session, so before we go to the after party. So at least you'll have a chance to talk to Michał and share the contact info. So for now, please, thank you, Michał, for
Thank you.
giving the speech.